In the winter of 1995, scientists pointed the Hubble telescope at an area of the sky near the Big Dipper, a spot that was dark and out of the way of light pollution from surrounding stars. The location was apparently empty, and the whole endeavor was risky. What, if anything, was going to show up? Over 10 consecutive days, the telescope took close to 150 hours of exposure of that same area. And what came back was nothing short of spectacular, an image of over 1,500 distinct galaxies, glimmering in a tiny sliver of the universe. Now, let's take a step back to understand the scale of this image. If you were to take a ballpoint pen and hold it at arm's length in front of the night sky, focusing on its very tip, that is what the Hubble telescope captured in its first deep field image. In other words, those 3,000 galaxies were seen in just a tiny speck of the universe, approximately 1/2 millionth of the night sky. To put all this in perspective, the average human measures about 1.7 meters, with Earth's diameter at 12,700 kilometers. That's nearly 7.5 million humans lined up head to toe. The Apollo 8 astronauts flew a distance of 380,000 kilometers to the moon, and our relative small sun has a diameter of about 1.4 million kilometers, or 110 times the Earth's diameter. A step further, the Milky Way holds somewhere between 100 to 400 billion stars, including our sun, and each glowing dot of a galaxy captured in the deep field image contains billions of stars at the very least. Almost a decade after taking the deep field image, scientists adjusted the optics on the Hubble telescope and took another long exposure over a period of about 4 months. This time they observed 10,000 galaxies. Half of these galaxies have since been analyzed more clearly in what's known as the Extreme Deep Field Image, or XDF. By combining over 10 years of photographs, the XDF shows galaxies so distant that they are only 1/10 billionth the brightness that the human eye can perceive. So what can we learn about the universe from the deep field images? In a study of the universe, space and time are inextricably linked. That's because of the finite speed of light. So the deep field images are like time machines to the ancient universe. They reach so far into space and time that we can observe galaxies that existed over 13 billion years ago. This means we're looking at the universe as it was, less than a billion years after the Big Bang, and it allows scientists to research galaxies in their infancy. The deep field images have also shown that the universe is homogeneous. That is, images taken at different spots in the sky look similar. That's incredible when we think about how vast the universe is. Why would we expect it to be the same across such huge distances? On the scale of a galaxy, let alone the universe, we're smaller than we can readily comprehend. But we do have the capacity to wonder, to question, to explore, to investigate, and to imagine. So the next time you stand gazing up at the night sky, take a moment to think about the enormity of what is beyond your vision, out in the dark spaces between the stars.